Process improvement creates the positive return required from your DCIM investment. More tools or different tools are only part of the solution. Better management of workflow is the critical factor. What obstacles contribute most to a less than optimum workflow? Customers have identified 4 that seem to be universal. Workflow monitoring and measurement, focused communication and alerts replacing broadcast communication, flexible workflow definition by the people who do the work, and active integration with a DCIM database. Obtain Nexus is engineered to maximize your DCIM investment by addressing the critical blockage you may be experiencing in your workflow process. Let's look at each of the 4 key factors, starting with workflow definition. People work best when they have control over how the workflow is designed. This is especially true in complex, ever-changing environments like data centers. Teams of people come together to accomplish daily changes and special projects. The teams often cross organizational boundaries and are geographically dispersed. Too often we see extended efforts to reach a consensus, with a pretty set of Visio diagrams created and then ignored. Why? Everything changes so quickly. Special circumstances often override agreements. Team members change. Management is unable to monitor the process and ensure compliance. Obtain Nexus workflow revolves around a catalog of services designed by the people who do the actual work. In a fast-paced organization, people come together to perform the services required day to day and in special projects. They form work groups. A work group has a leader and a group of people with expertise. They design a set of services for the work they can perform, either as a standalone service or as a component in a larger service or project. A service has a set of tasks. Our example service receives equipment ordered by a service requester. The task map can be easily modified with new tasks or dependencies. This service starts with a task that presents an input form to the service requester. Equipment has been ordered. Before it can be received during this service, the requester must tell us what they ordered. The next task is an automated function. Obtain Nexus converts the contents of the input form into a standardized list, usable by multiple DCIM processes. The equipment list is passed to a task, which ensures the DCIM database contains accurate and complete model definitions for the equipment. This task is performed by a completely different workgroup, as indicated by the yellow highlight. The capacity to have services call other services enables complex projects to be quickly designed from small, locally controlled service blocks. Another task in this service performs the actual work of receiving the equipment at the loading dock and unpackaging it. Our example service contains another automated function to create DCIM database records for the new equipment. Automated functions save manual work and ensure your DCIM database contains more accurate and complete data. The last task in this service prepares the new equipment for installation. Let's look more closely at the properties of the first task in our service, Present Input Form. This task presents a form designed by the workgroup to collect information related to the equipment ordered. The task is started immediately, though the workgroup could have included a task acceptance step in the process. Likewise, the task ends automatically without review. The input for this task is from an input form named Equipment Receiving, OCS, designed by a member of this workgroup. The input form is presented to the service requester and is approved by automated functions in Nexus, but manual approval is also an option. During a task, work can be performed by members of the workgroup, an automated function, a web service called to another tool or database, or in this case, by the end user who requested the service. Output from the task will be the contents of the input form. This task does not require any notifications to be sent to members of the workgroup. After the user fills in the input form and submits it, the first task will complete and notify the second task to start its execution. It is an automated task indicated by the green highlight. It transforms the input form contents into a standardized equipment list, which can be used by many DCIM functions. The next task to execute calls a service performed by a different workgroup, It is their responsibility to ensure the DCIM database contains accurate and complete model definitions. Their service requires a standardized equipment list. Our service passes the one just created. Their service will use a combination of automated and manual tasks to check the equipment ordered and associate each item with a model definition from the DCIM database. The modified equipment list is passed back to this service. Meanwhile, back in our service, a concurrent task starts to inform members of our work group that equipment has been ordered. This task will send notifications to the selected members of our work group and present them with a means to receive the equipment and record new information, such as serial numbers and asset tags. We can look at the details for the Receive Equipment task to see how it is designed. The input for this task is the equipment list created by the previous task. The work done during this task is performed via interaction with the Nexus dialog function. This dialog will present the equipment order list to the viewer and collect new information such as serial number and order status. The ability to collect information once, at the first moment it becomes available to your organization, and then flow it automatically to whatever process or generated view requires it, is a key advantage of a true DCIM database and integrated process control. Reduced work? Only one copy of any piece of data? More complete and accurate information. This task requires selected members of the work group to perform some manual work. They need to be notified. 3 people are responsible for receiving equipment at this data center. After the equipment arrives and has been received, another manual task will be performed to assemble the hardware and make it ready to be used. The task is designed as a checklist of items to inform the worker what needs to be done and collect the status of each piece of work. Now that we have seen how the service was designed, let's see the workflow as it executes. The service can be requested from a published catalog using a standard request form. The user fills in the request ID, selects the service, provides a request description, and optional fields. The service could also be initiated via a web service request from another tool, such as Remedy, which would pass the data to obtain in lieu of manual input in this form. When the user fills in the info and presses Submit, or a web service initiates the request, Obtain Nexus executes the requested service. The first task in our example service presents an input form to the requester. The input form is partially filled in with information already known, such as the request ID. The user must fill in the details of what equipment they ordered. In this case, 2 IBM 7028 servers and 2 Cisco 3750 switches were ordered and need to be received at the OCS data center. When the user submits the form contents, Nexus completes the first task of our service and initiates dependent tasks. One of the tasks, Receive Equipment, requires manual work, and notifications are sent to the selected members of the work group. Here you can see a new notification in my work queue. It will remain there until the equipment has been received. When new equipment arrives, I would open the notice in my work queue. 2 other people also received this notice. When I click Receive Equipment, a Nexus dialog presents a list of equipment which was ordered. I can check each item against the actual equipment received, enter new information such as serial numbers, and change the item status to Received. When all of the equipment has been received, the notification in my work queue and the work queue of the other 2 members in my work group is deleted. The equipment task is now finished, so Nexus initiates a dependent task with some checklist items. A new work notice appears in my Nexus queue to inform me that I'm responsible for this work. When I open the notice, we can see that I am the only member of the work group who received this notice. I can open the notice, see what work needs to be done, and report the status as I do the work. When all of the checklist work for this task is finished, the work queue notice is automatically deleted. The service work is now finished. Part of the work was an automated task, which used input from previous tasks to create new DCIM database records for the new equipment. We can see the new records by going to the device section of the database. When we enter the device dialog, information for the device we last viewed is displayed as a default. We can view a complete list of the devices in this data center and then filter to a list of only the devices that have been changed in the current work order. Here are the 4 new devices automatically created in the database by the service execution. If we select device 1111, we can see it is an IBM 7028 Unix server. The model definition for 7028 specifies it has 2 multimode fiber ports as a default. Let's suppose that a continuation of the workflow would involve connecting this device to a switch. The person designing the connectivity may have no awareness of or responsibility for physical connectivity. Their job is to decide which network zone will be connected to. This decision can be documented immediately when it is decided via a logical cable. A logical cable in obtained DCIM means the physical path has not been decided yet. But we do know the network zone, and we can document our decision to connect to the production network, Zone A. The ability to document decisions quickly, precisely, and completely as soon as they happen is a key feature of a true DCIM database and integrated process. Any process that documents decisions, actions, and new asset information long after it is first known will generate duplicate effort, incomplete data, and conflicting data. It will never achieve the results DCIM is capable of producing. After the decision to connect this device to Zone A was made, a person responsible for selecting the specific switch in the network can build upon the initial network decision. We will select one of our new Cisco 3750 switches. Switch 3, port 01. Yet another person might be responsible for engineering how the 2 device ports will be physically connected. They may decide to use a set of patch panels in the path. Obtained DCIM automatically inserts the selected panel and its trunked twin into the path and creates a second logical cable to indicate 2 patch cords will be required to complete this path. The person who runs the patch cords would document which cables they used from the spare cable inventory. Obtained Nexus is fully integrated with the Obtained DCIM database. Your DCIM investment reduces manual work, improves data accuracy and completeness, focuses the process communication to the specific people who need to know, provides monitoring and metrics so management can improve the process and plan for the future.